So hi everyone, you can see this is the experimental setup for to determine the Young's modulus using searls apparatus. So searls apparatus is used to determine the Young's modulus. So it consists of two wires of equal length. So these wires are connected to a rigid support. To determine the Young's modulus of elasticity of the material of a given wire, the apparatus searls apparatus two long steel wires of the same length and diameter, a meter scale, screw gauge, 8.5 kg slotted weights, 1 kg hanger. Here the apparatus required are, this is the searls apparatus and two wires, steel wire, slotted weights, screw gauge to measure the diameter of the wire, and this is the standard weight or unknown weight we can call, and meter scale to measure the length of the metal wire. So this is the formula to calculate Young's modulus by searls apparatus. So Young's modulus is given by the ratio of normal stress to the longitudinal strain. So normal stress for this experiment we can write here the mg divided by pi r square. M is the mass and g is the acceleration due to gravity. R is the radius of the wire that we are using. We have to substitute. And L by change in length to the original length, longitudinal stress. So Young's modulus formula is mgl divided by pi r square by small l. You should know the parts of the searls apparatus. So here is the air bubble. Here is the air bubble. This is the spirit level. And this is the spherometer. This is the pitch scale. So the number of divisions on pitch scale are 10, left and right. This is the disc. So or the rotating scale which has 100 divisions on it. And these are the weight hangers. So here we have to use the screw gauge to measure the diameter of this wire. Okay. So use the meter scale to measure the length of the wire. So first we should note down the observation here. Length of the experimental wire, diameter of the wire. If we know the diameter of the wire, we can measure using screw gauge, and the radius of the wire we can calculate by dividing diameter by 2. So next, least count of the spherometer, that is on the searls apparatus. We are going to get here 0.001 centimeter. Least count formula is given by ratio of pitch scale on gauge to the number of divisions on circular scale. 0.1 divided by 1000 is equal to 0.001 centimeter. So as we have the two wires, one we should take it as the reference wire and one we have to take it as the experimental wire. So to remove chunks in the wire, we have to hang the unknown weight here. So to reference wire, and for the experimental wires also we have to load the weight to remove the chunks in the wire. Check the two wires are on the same horizontal level. So the spirit level we need to adjust such that the bubble must lie on middle of these two markings. So as you can see, we have hanged the standard weight to the reference wire, and here the slotted weights we can use each time, and we have to note down here the pitch scale reading and the circular scale reading. Keep on increasing the weight and note down the pitch scale reading and circular scale reading each time. So here I have added the weight. So here this is the steel wire, so we don't observe much stretch in this wire. So here as you can see, the circular scale is touching to the 5th division or the 6th division on this pitch scale, and the circular scale is touching to the pitch scale is around 71. So like that you should note down after applying or increasing the weight, and in the similar way you have to note down the readings for unloading, decreasing the weight. So 2 times you have to take. First you need to load, and next you have to take the reading for unloading. Here is the tabular column. So first we have to note down here the loads on hanger in the increasing order. So from 0 to 0.5 kg, 1 kg, so up to 4 kg. So total 9 readings you have to take here. So spherometer reading you should note down. Once you without applying load, you should note down the spherometer reading for loading, and you can start increasing the weight. Apply the 5 kg weight to the experimental wire, and then go on increasing the weight and note down the spherometer reading for loading. And unloading, you have to decrease the weight and note down the reading of spherometer. Then once you note down these 2 readings, you can take the mean. For all the 9 readings you should calculate the mean. So extension, if you want to calculate extension for load 2.5 kg you should take. Here is the 6th reading, 2.5 kg you should take. So length you can measure here, extension, how much has happened. L1 is equal to, you should subtract here in the 6th reading mean Z6 minus Z1. So L2 Z7 minus Z2. So like that. L3 Z8 minus Z3. So L4 Z5 minus Z9 minus Z4. So like that you should calculate the extension of the load. The extension, mean extension for 2.5 kg load, you take the mean of the 4 lengths. L equal to L1 plus L2, L3 plus L4 divided by 4. Then once you get the value of L average, put that value in the formula. So here M is the mass, mean extension for 2.5 kg. 2.5 you can write G acceleration due to 9.8, L original length of the wire, and R is the radius of the wire, and small l this average value for the extension of 2.5 kg you can substitute. You are going to get the Young's modulus. So at the end you can write the result here. Young's modulus for steel as determined by searls apparatus, the unit is Newton meter square. And the second one, here the straight line graph between load and extension shows that the stress is directly proportional to strain. So here according to Hooke's law, the stress is directly proportional to strain and the graph is going to be linear. So you should plot here from tabular column load versus extension. So that must be a straight line.